Hello, everyone, and thanks for coming to my presentation. My name is Nick Swaya. I'm a data scientist, and I'm here today to share my experience creating an exciting project I've been working on over the last few weeks, PacMan AI. The aim of my project was to use reinforcement learning to train an agent, PacMan, to navigate through a maze and eat pellets while avoiding pesky ghosts. This project was inspired by an existing program called Snake AI, developed by Michael Seguin. His project implements deep Q learning to train an agent to play the arcade game Snake, and seeing it in action was both mesmerizing and exciting. I originally wanted to expand on his project by adding in obstacles for the snake to learn to navigate around, and I'm happy to say this was a success. And this was my first time digging into a stranger's repository and trying to understand what they had envisioned well enough so that I could maybe manipulate it. This really clicked for me, and I was inspired to not just expand on this existing code, but to create my own learning program from scratch. I found a PacMan game written purely in Python created by Jonathan Richards, and his code isn't on GitHub, so that link will just take you to his website where you can download the code for yourself. And I followed his tutorial and created the game for myself in Pygame, which is a Python library created for basic game development. The game behaves exactly as you'd expect it to, with PacMan reacting to user inputs through the keyboard. But my goal was to have PacMan move not based on user input, but through predictions generated with a deep Q network, the same algorithm used by Snake AI. There are three main components when creating a deep Q network, the first being state. And the state can be thought of as what the agent or PacMan is seeing. There are a number of things that you can mess with state, such as how much information you want to give your agent. For PacMan, I chose to give him information on ghost coordinates as well as his own. The second component is action, which is exactly what it sounds like. PacMan has five different actions available to him: left, right, up, down, and stop. The last component is reward, or how the agent is rewarded or penalized based on taking certain actions. And I experimented a lot with rewards with PacMan AI, but one constant reward I used was having each pellet reward 1 point. I want to break down what my inputs and outputs look like for the model I built. I mentioned earlier I gave our agent PacMan his position on a grid, as well as the 4 ghosts. And these positions create a 10-digit array that make up my input layer. These are fed into a dense layer before being output into a 5-digit array, predicting the best action to take to maximize reward. To create this program, I first built my model following the format I just mentioned in Pytorch, a Python library for creating deep learning projects. I then needed to get the game state at each tick. And a tick is a measurement of time within Pygame, and the game updates after each tick. And additionally, I needed to store the agent rewards after each tick, as well as checking to see if each episode, or in this case, a game, was over. And once this was gathered and cleaned, I fed it into my model to get a prediction. One of the bigger challenges I faced was figuring out how to go from this 5-digit array output into an actual game action. But I was able to accomplish this by mapping each of the 5 possible outputs to a simulated key press. After training, the model should be able to take reward maximizing actions based on the input game states, although that unfortunately was not the case. I left PacMan training for the night, but was disappointed to find him running into the wall in the morning. As you can see, PacMan doesn't seem to be improving with each training iteration. I didn't see performance increases regardless of how I tweaked the hyperparameters or changed the structure of the game. The agent would mostly run into walls or simply disregard the ghosts. The figure on the right is a control group for reference, performing solely random moves. And unfortunately, PacMan AI was unable to perform better than my random baseline. There are quite a few culprits behind the agent's mediocre performance. It's difficult to know how long the agent needed to train before I was satisfied that a run was either a success or a failure. Additionally, the complex nature of PacMan, at least relative to Snake, also meant that my inputs were more complicated. The agent needed to track all 4 moving ghosts, all of which have 4 different personalities. There's also no set of rules on how rewards and penalties should be applied. As I mentioned earlier, I experimented a lot. And finally, there are just a ton of hyperparameters to mess with in this model. I do want to close by saying that although my model didn't perform as well as I hoped, I think it was a success. In my opinion, reading someone else's code is the quickest way to improve because you're forced to interpret and understand concepts that you otherwise might avoid when coding something for yourself. And for me, this was object-oriented programming. In the future, I would really like to get PacMan AI up and running without having to actually animate his actions, because this slowed down my training time considerably. It feels like I've done all the heavy lifting of linking all the parts together, and I'm hoping I can eventually make the right adjustments to beat level 1. Here's my contact information if you have any questions.